Hello students, welcome back. In this video we are going to learn about some theorems which are related with circles. Here we'll be learning about the perpendicular which is drawn from the center to a chord. The related theorem is given here. It states that the perpendicular from the center of a circle to a chord bisects the chord. Okay, bisects the chord. What does this word bisects means? Bisects means to divide the chord into two equal parts. Okay, divide the chord. That means the perpendicular which is drawn from the center of a circle to any chord divides the chord into two equal parts or bisects the chord. The proof of the theorem is not required here. Okay, and if you need to prove the theorem, you can prove it like this. Draw the circle. Okay, this is the center of the circle, this is the chord. Draw the perpendicular. AB is the chord, this is the perpendicular, and you have to join these two. Okay, now this is O and take it as C, this as C. So the proof is not given, but still if you want to, you can prove it. Now if you take from triangle AOC and triangle BOC, from triangle AOC and BOC, if you take, what you can find here, that this angle OCA and angle OCB, they are equal, they are right angles. Okay, right angle. Then OA is equal to OB, common radii of the same circle, OA and OB. If you look at here, this ON and OB are equal, common not common radii, same radii or radii of the same circle. And last one, if you see, OC equal to OC, OC equal to OC, that is the common side. Okay, this one, OC equal to OC, common side. Now by RHS, okay, by RHS, right angle, hypotenuse and side theorem, they are congruent. These two are, but you can say these two are congruent. So when these two triangles are congruent, then what we can write? AC will be equal to BC. That means C is the midpoint here. Okay, C is the midpoint here. Here C is the midpoint. This part equal to this part means what? OC divides, or OC bisects AB into two equal parts, or bisects AB. That is the way we can prove this one. Okay, now this is the converse of this theorem. What it states, you see, theorem 10.4, converse of theorem 10.3, that the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Okay, that means now if you draw a line from the center of a circle to any chord such that it divides the chord into two equal parts, then we have to show that this line which is drawn from the center to the chord which bisects the chord is perpendicular. That means it's 90 degree. This one we have to show as 90 degree, or OM perpendicular to AB. So the proof is done here. Same way as we have done there, you have to take the circle and then you have to take both the triangles. That is, one triangle it is this one and the other triangle is this one. Okay, we'll take both the triangles into consideration. Then we can see this side is equal to this side, common radius. Sorry, every time I'm saying common, it is not common radius, radii of the same circle. Okay, then this side common side, and this AM equal to BM by SSS, they are congruent. See, it is given there, this three. So when they are congruent means what we can write from here, that this OAM and OBM triangle are congruent means their angles are also equal by CPCT. So this angle is equal to this angle. Okay, now we know that AMB is a straight line. When AMB is a straight line or AB is a straight line, what we can say, so these two are equal. That means what, each will be 90 degree, so is equal to 90 degree. So they are, that means this OM, okay, is perpendicular to this AB. This is the proof. Okay, now this part, this circle through 3 points which is excluded from the syllabus. Okay, just I will just ref what it says. That means there is only one and one circle passing through 3 non-collinear points. If you have 3 non-collinear points, okay, they are not collinear, you can draw only one circle through this 3 points A, B and C. That is what. Okay, this is not included, but non-collinear means they don't fall on the same straight line. So this A, B and C, if you will see, this A, B and C, this A, this B and this C are non-collinear. Okay, they don't fall within the same straight line. So you can draw only one and one circle through 3 points which are non-collinear. This is not required, but I have explained it. Okay, so this part is also not required. If you take this exercise 10.3, how many circles, this is not required. Suppose you are given to find the center, also not required. This exercise is not required, so we will not go through this. Then you see the next theorem, we'll learn about the next theorem. Before that, we have to know, we'll be learning about equal chords, okay, and different theorems related with this equal chords. Now, one thing you have to remember, the length of the perpendicular drawn from a point to a line is the distance of the line from the point. We know that the perpendicular distance is the shortest distance. Okay, if you look at here, this PM is perpendicular to this AB, and it is perpendicular, and it is the shortest distance. Perpendicular means it is 90 degree. So remember, the perpendicular distance between 2 points is always the shortest distance, or is always taken as the distance of any 2 points. That means if you take 2 points here, say this point and this point AB, okay, Now if you join, you can join different ways, in different ways. Like this you can join, then you can join this way also. There are many ways, but this one, if you join, this will be the, so if you take that means the shortest distance. Actually if you draw a line here, this means this will be perpendicular, then this distance will be the shortest distance actually. Okay, the perpendicular distance between any two points is the shortest distance between the point. Or when you say about distance, when you talk about distance, this is the this perpendicular distance is always taken as the shortest distance. Okay, or the distance of any two points. Now we'll go through the theorems given here. Equal chords of a circle or of congruent circles, whatever it is, are equidistant from the center. Equal chords of a circle are equidistant from the center of the circle. Or if you take any congruent circles, congruence means both the circles are equal. So that means if you draw a circle, now say this is the center. If you take this as one chord, this is one chord, this is a chord AB, and if you take this CD as another chord where AB is equal to CD, they are equal chords, then remember their distance from the center of the circle, both are also equal. If the center of the circle, both are equal, that means if you take this as say P, this point as P, and this point as Q, okay, then what we can write, this OP is equal to OQ. That means they are equidistant from the center of the circle. You can take for congruent circles also. Congruent circles means if both the circles are same. If both the circles are same, that means of equal size, then if you take any two chords, equal chords, say AB and say PQ, here let it be O dash, this one as O, then this perpendicular have to draw. Okay, when we are saying about, when you're talking about distance, we always draw perpendicular. So this, so if you take as C and this one as, and this as M, so this OC is equal to OM. That means they are also equal, this and this equal. Okay, you have to prove it also in the other one. You see, it is the converse of the theorem. That means the chords which are equidistant from the center of a circle are equal in length. This is the opposite or converse of the theorem 10.6. that means chord, if you draw chords which are equidistant from the center of the circle, then they are equal in length. That means the chords are equal. This one, if these two OL and OM are equal, then this PQ and RS, they are also equal. Okay, this is the converse. Now how to prove? For proving it, you can just although the proof is not given here, but you can also prove by yourself. Okay, how? So draw a circle again for the same circle. Okay, and then draw a chord, these two are equal chords for the first one, AB and say PQ, and these two are the perpendiculars drawn from the center of the circle, say O, and this one let it be C, and this is M. So for the first theorem, that means for 10.6 you have to show this, and that this OC and OM are equal. Okay, and you are given AB equal to this PQ. So you can take this triangle, you can take this triangle, and you can take this triangle. Okay, now if you take from this triangle, from the previous theorem, we know that this PM and this MQ are equal, and this AC and BC are equal, because perpendicular, these are perpendicular drawn from the center of a circle to any chord bisects the chord, and AB and AC are equal. AB and PQ are equal. So this AB and PQ are equal. That means half of AB is also equal to half of PQ. Half of AB equal to half of PQ. So we can say half of AB, what we can say, this AC is equal to PM, we can write. Yes. So this is the first one. So when we consider these two circles, or these two triangles, which are the triangles? We'll consider two triangles, that means triangle AOC and triangle POM. Okay, there you can see this AC equal to PM, first one. Yes, and then this angles, they are right angle triangles. So these angles are ACO equal to PMO. Both are right angle triangles, both are right angles. Okay, and OA is equal to, this OA is equal to OP. OA equal to OP. Why? Because they are the radii of the same circle. So that means by SAS they are congruent. These two triangles are congruent by SAS. When they are congruent, their corresponding parts will be equal. So the remaining corresponding parts are, if you see, already AC and this PM already they are equal. This OP and OA they are already equal. Remaining third side will be equal. That means OC is equal to PM. Sorry, not PM. OC is equal to OM. OC is equal to OM. Now this is the proof. Okay. Same way you can prove for the for 10.7 also. You take AB, you take PQ. Okay, now it is said you have to show that AB and PQ are equal. So from O you draw this perpendicular, from O you draw this perpendicular, this you take as M and this you take as C, then join the triangle, make the triangle, this one. Now how to prove this one? You have to show that AC equal to PM, and when you can show that AC is equal to PM, then you can show double of AC is equal to double of PM. That means AB equal to PQ. Chords will be equal. Okay, so how to do first one? You will take both these triangles, this side equal, Okay, or you can take RHS also. Yeah, you can take RHS. That means this right angle and this right angle equal, hypotenuse are equal, radii of the same circle, and this side is equal to this side, one side. So by RHS they are congruent. When they are congruent, that means their corresponding parts will be equal. So what is left is AC is equal to PM, and we know that OC and OM are perpendicular to AC, AB and PQ, and it bisects. That means what? It bisects the chord. The perpendicular of a circle drawn from the center to any chord bisects the chord. So that means this AC will be equal to this BC, and this PM will be equal to MQ. So you double of AC is equal to double of PM. Okay, double of AC is AB and double of PM is PQ. This is the way you can show that the chords are equal. Okay, so then we'll head on to the exercise. Thank you.